Hello, everybody. We are restarting the Space of That event. Today we have the great presence of Michael Lorrey. I have some words about the profile of Michael Lorrey. He's working about blockchain, VR, and also he's part of Galaxy Systems, a company committed with some services about virtual reality, also developing different projects in the virtual reality softwares and platforms. He's also acting as entrepreneur, developing many achievements in virtual world. Yes, and also he has some specialities related to virtual reality and blockchain, cryptocurrency, augmented reality, aerospace, energy, and also business development. And Michael, you are very welcome to present your achievements and related to create this platform on virtual reality. Please explain everything what you are developing and the great achievements developed by you. Okay, you are very welcome to, and we have something around 30 minutes and more time for discussions and contributions. And thanks so much about your application to be part of Space of Thought event. Okay.
All right, thank you very much. So my experience in virtual reality goes back well over 20 years. And back when I was, before that, I was developing flight simulators for the X-Plane platform, and I developed the flight sims for the X-Core Aerospace's Easy Rocket and Xeris rocket plane projects. And going all the way back to my Air Force experience in the late 1980s. So I've got quite a bit of aerospace experience there and in other venues. I joined this organization called the International Spaceflight Museum in 2016. They are a group that began in the virtual world of Second Life in 2005, and they have since expanded into a platform called OpenSim, which is essentially an open sourced version of Second Life. And it gives us a lot more room to develop. And so I basically run the entire facility in OpenSim for the Spaceflight Museum. And I've been developing beyond the normal museum exhibits of all the world's rockets and spacecraft and probes and astronaut exhibits and so on and so forth. A special project we have here is our Mars base training facility. And so this is based on the idea that if groups like SpaceX, et cetera, the Mars Society, are setting a goal of having 1 million people on Mars by the end of the century, this is going to require a rather large increase in the training throughput to get people trained up to actually live on Mars, because Mars is a lot more deadly to people than prior exploration and colonization efforts in human history. For instance, the American West, South American explorations, et cetera, et cetera. And most people in those eras came over with little training, and they basically, those that survived did, and those that were not capable of doing so didn't. And that's a pretty brutal thing. So we don't want that kind of a record with the Mars effort. So we're trying to create sort of a stepped approach to training. So you've seen with other presentations the great work with real world analog astronaut training programs like Julio's in Brazil, like the Mars Society here in the US and Utah, and other facilities run by NASA and so on and so forth. So our goal is that, number one, we're expecting these real world efforts to ramp up in their training capacity in the coming decades, but we need to make sure that those that go through those expensive real world training programs are actually qualified to go through those programs. So, the best of the best are going into those and coming out so that they have a high chance of success in training, and so they'll go on to Mars. So what we're doing here is we're creating this virtual training environment where people can learn all the information, the processes, and so forth about how to live on Mars, how the machinery works, how the technologies work, and we're building it so it's a sort of a gamified environment. So you don't just learn how to operate things, but there will be aspects where the equipment will virtually break down. You'll have to troubleshoot it and repair it, and if they aren't replacement parts, of course, you're going to need to make replacement parts from local resources. So it creates this whole gamified approach that's sort of like, something like EVE Online or World of Warcraft, where you have to actually do all these things that are really going to happen to people on Mars, because making Martian colonization affordable for as a project is going to require, depending largely upon the in situ resource utilization technologies we'll be developing. So we want to make this a holistic approach where people can come in and go beyond just learning how to run things, but how to fix things, how to build things, and so on and so forth, and do it in the virtual environment, and earn a competency certificate from that they can then use to move on to, if they actually want to pursue this as a life to pursue, to go into real world training that is going to be a lot more in-depth and personal. So we see ourselves as sort of a feeder or farm team type of program, and to help bring in the most qualified people to the real world projects like those run by Julio, etc. So here we're in our Mars base simulation area. It's a little over a half a kilometer wide. It's set within this crater terrain that we've created. And we're going beyond just a few modules on the surface, like the first effort. We're imagining a facility where there's been probably 3 to 4 cycles of ships coming from Earth to Mars, dropping off equipment and people, developing local resources, and having this facility is being built to house a couple hundred people at a minimum, and do so comfortably and be able to support them. So looking at this from a distance, we've got a couple landing pads for our Starship rockets. These are scripted to actually take off and return to the main museum facility, where we have a landing pad there, and so people can actually jump on the SpaceX rocket, fly it up into space, experience zero G, and come back down, land here on Mars, and get the whole experience of landing and going through quarantine, and then experiencing all the different technologies. So that's what's set up for the trainees. For everyone else, people who just want to visit, we have a normal landing place for people to teleport to when they come from someplace else in the OpenSim hypergrid, as we call it, and then just come here, and they can get a free spacesuit they can put on their avatar to role play the experience here. So once they arrive, you've got your transporters. We've got our quarantine entry here that will take them underground to quarantine facilities right here. Then we've got our going past our landing pads. We go over to our first ISRU technology, which is the Sabatier fuel processing, which you've probably read about or seen with like Bob Zubrin's videos and so forth. So here we've got a large size. It's very simplified. It's not going to look exactly like this in the real world, but this is simplified so people understand the process more than anything. So here, of course, we've got a facility where we can bring in Martian water, goes into the purple tank, We have a turbo compressor that creates compressed CO2 in this tank. And electrolysis splits the H2O into LH2 and LOX. So the LOX goes over into the blue tank. Liquid hydrogen goes in the green tank. And then the hydrogen and carbon dioxide go into this reaction chamber that has a bed of platinum catalytic pellets in it and this big induction coil. So we take energy from solar panels, from windmills and so forth, and run it through this induction coil to heat up the mixture that's inside. It gets catalyzed by the pellets and turned into steam, water steam, and liquid methane, or gaseous methane in this case. And so the hot gaseous mixture comes out, goes through a first condensation stage that condenses the water. Water goes back into the H2O tank, and then the remaining methane gas goes into a second condensation stage, and it winds up in this orange tank as liquid methane. So we wind up with the fuel and oxidizer we need to refuel our rockets to send back to Earth to get more people and cargo. So this is and so we're going to have our control. We've got our control panel here, and so users would be able to control this and start the process and see how the various levels in the tanks change as the process completes, and there'll be indicators of where failures may occur that they're going to need to troubleshoot and repair and so forth, and so on and so forth. So this is one example. We're doing this sort of repair, troubleshoot, gamification with everything. For instance, we've got the rocket's got its own failure modes. We've got two types of windmills here. We've got helical windmills here to deal with the swirling wind that winds up in this crater. And then we've got larger bladed turbines up on the rim of the crater to pick up the more sustained directional winds that happen outside the crater. For a more reliable baseline power, we have this MP200 nuclear reactor, which is a plutonium reactor that basically heats up liquefied metal. The metal provides heat to these 4 Stirling generators. Each one's going to be 50 kilowatts and has just one moving part on each of them. And they will work without any kind of maintenance for at least 6 years. So it's a very low maintenance. So between the 4 pistons for the 4 generators, and then you've got the control rod in the plutonium core, so that when power is cut to the control rod being held up by an electromagnet, the rod just drops right down into the donut-shaped plutonium core and stops the reaction in its tracks. So it's an inherently safe design. And of course, we've got this in the side crater for additional radiation protection. And the waste heat gets dumped right into the Martian atmosphere to provide heating to the open environment, which will basically helps to contribute to the gradual terraforming. Here we've got RASOR, Martian regolith mining robots. So they've got these drums with blades that scoop up the dirt, and the dirt goes in, the Martian regolith goes up into these drums that are rotating. And when the drums get filled, the pistons pull those arms up, and the drums rotate in the opposite direction to dump their contents into the bin. When the bin fills up, the machine heads off over to the ramp, and it dumps the regolith onto the conveyor and goes into the regolith refining facility. So this is a full cycle ISRU process we're simulating here. And so then we can go in to the interior. And the way we've got this designed is we have essentially a 4-stage of development design here. So the first stage is this module that's designed like a Mars Direct, essentially the same dimensions as a Mars Direct module. So this will be the first module that'll be assembled on Mars, and where the first crews will live and work as they start developing local resources. And so then they'll bring in their large 3D printing machines and start building the first locally built modules, which will provide bunk space and storage space for crew and supplies. So we're going to have 4 of those modules going off in each direction with multiple airlocks for redundancy. So this is stage 2. And this hatch goes down to a lower pod that goes down to the first well water tap that supplies water to the facility. And then we go through to stage 3, which is our universal habitat design. And so this technology is based upon the sustainable agriculture work of Greg Allison at Huntsville. He's a NASA rocket engineer who's been doing a lot of work on sustainable agriculture. He's been featured on a number of TV shows that have focused on this sort of thing, like Doomsday Preppers shows here in the U.S., among others. And he's got his own a couple of channels on YouTube. One is Green Greg's, and the other one is Galactic Greg's. And you can see his shows there on YouTube. And so we've got essentially a closed system. We've got these large glass bowls with water that are hanging from the geodesic dome here to weigh it down against the pressure. The glass is leaded glass to provide radiation protection. The water in the bowls provides additional radiation protection. They're used to grow algae and small baby fish as in the first stages of development. And the heat from the sun will, of course, evaporate the water, which will condense against the glass, and it will flow down into these gutters on the edges and go from the gutters into the terrace system to grow various crops, wall hanging crops like beans and peas and grapes and so forth, as well as other crops in the terraces of all types. And the water eventually winds up in the main cistern where the fish grow into larger organisms so they can provide a good protein supply to the facility. We use this facility here often for events to promote the facility in the OpenSim community. So this is why we've got the stage here over the cistern. And the rest of this facility, we've got living and working facilities. So this is both a living, working, and agricultural facility. So down the lowest level, we've got bunks for colonists. And then the upper levels, we've got offices, we've got kitchen facilities, so on and so forth. And of course, the bunks are the bunk rooms are at the lowest level to provide the most radiation protection. So that is the 3rd stage. And we'll go down and we'll go into the 4th stage. So the 4th stage will be when the big boring company tunnel boring machines show up in the Starship Mark II design. And they'll be able to bore large tunnels underground. So here's stage 4. So we'll be having tunnel boring machines boring tunnels and having 3D printers going right behind them, printing up modules for living and working and storage space all through here. And you notice how each one of these modules has these steel thresholds. So there's doors for each one of these so that each module will have its own air, water, energy supply, so that if a Marsquake comes along and misaligns the modules and springs a leak, of course, the doors can lock up, and to seal those modules until the seals are repaired. And so anybody that's stuck within those modules will have their own supplies, just like, being in a spaceship. So each module will be sort of a spaceship in its own regard in that respect. Here's a larger module that is large enough for a decent sized family to live and work in. We can build a second floor above the thresholds here for more living space. And this module is sort of based on the siege concepts from science fiction, from the Dune series, where you recall that the Fremen lived in these desert habitats, and they would collect the very scarce water from the environment and store it in these underground lakes. So under each one of these large circular modules, we have a cistern that'll be used for storing water for long-term use. In this particular module, we have an exhibit about all the different probes that have been sent to Mars, ones that are operational, ones that have succeeded, some that have failed, and so forth. So we use these facilities now for different types of exhibits. So with stage 4, we're going to be expanding the agricultural facilities. And so we've got this 4-story tall agricultural module that provides light to these 4 stories, provides a lot of 3D growth capabilities at all levels. And we've got a bigger cistern down here for storing more water. And I've designed this big enough, you could theoretically have a rowboat down here and row around it if you wanted to. And so we've got a wider variety of crops here, everything from pineapples to strawberries to carrots and so on and so forth. So we've made all these different sort of crops. My partner Rosa, who's in the audience here, has focused a lot on making the different plants that we have, and we're scripting those up to actually be they will grow. So you'll be able to plant them as seeds, and they'll grow into full-size plants, and then harvest them and so forth. And then the last thing we want to show off is we've got our own Hyperloop train here. So of course, living on the surface of Mars, there's too much radiation from long-term exposure, and you can't really travel between distant colonies on the surface because of that radiation exposure. So another reason for the Boring Company is to dig tunnels to create hyperloops between different Martian colonies. So we've got our own Hyperloop here that cycles between this station here, and there's a station over at the quarantine facility that's under where the rocket landing pads are. So here we've got our station, we've got some nice promotional posters, we've got our Mars coin ATM so that people can interact with the Mars coin monetary system to register prospecting claims, to register crops they've grown, to put them on sale, to interact with the global Mars-wide crypto economy with the resources and products they produce to allow for a very free and open market. So that's the extent of our talk today. I guess we can open things to questions if people have them.
Yes. Okay. Okay.
one thing we are developing for this here that people were talking about in one of the earlier talks is we're developing a virtual medical facility. So we have medical instruments that people can train on, quarantine facilities, as I mentioned earlier, as well as biohazard research. We expect that we may discover Martian life forms on Mars that we need to do research with. We expect that radiation may increase the rate of mutation of any pathogens humans may bring with them, and we need to deal with containing and dealing with those. So there's going to be quite a bit of biomedical research happening on Mars, we expect, and so we want to provide some training facilities for that as well.
It's very interesting. Yes.
There's a lot of different sorts of ISRU things here. So we were talking about the Rasor regolith mining. That will be able to provide Martian steel from the billions of years of asteroids raining down on Mars. So plenty of iron there, iron, nickel. So we expect that Martian steel will actually be an export commodity to supply steel to not just the local area of Mars, but maybe shipping to other areas of the solar system. There will, of course, be Martian concrete to help 3D print modules. There'll be Martian glass from silicates. And of course, one thing that we will be a long-term resource is going to be creating gases needed for terraforming Mars on the long term. And this is something that I've been researching for quite a while, and had long discussions with Dr. Martin Fogg, who has written the seminal textbook on terraforming. You can find his textbook on Amazon, titled Terraforming Engineering Terrestrial Worlds. And he's coded a terraforming simulator that I'm not sure if it's still available on the internet, but it has been as a JavaScript applet. I think they've modified it into another, I think with Python by now. But we've been able to simulate that if we are able to collect fluorite minerals from Mars, and the orbiters have found that there's plenty of fluorite minerals available on the Martian surface, is we can produce carbon tetrafluoride from that and carbon dioxide. And by producing only about 6,000 tons of carbon tetrafluoride each year for about 30 years, will produce enough global warming gases in the Martian atmosphere that it will warm the Martian environment up about 5 to 6 degrees Celsius. And that will trigger a massive outgassing of CO2, not just the dry ice at the poles, but also CO2 that's absorbed into the Martian regolith down to a depth of as much as 35 meters. And so over the next 30 to 60 years, the CO2 levels should rise to somewhere between 300 to 600 millibars of pressure. And as it reaches that pressure level, which is about the atmospheric pressure on the Tibetan plateau up into the Himalayas, that will be enough where people could actually work on Mars in shirt sleeves, but with an oxygen mask, since it's all carbon dioxide. And then the environment on Mars will shift into what geologists call a great oxygenation event by, number one, introducing cyanobacteria. The massive amounts of water we're discovering underground on Mars will thaw and start flowing and filling the Great Northern Basin of Mars, as well as some of the southern basins. And we'll start having a hydrological cycle. So we'll see clouds and we'll see rain on Mars. And as the rain falls through the carbon dioxide atmosphere, that will recreate carbonic acid in the rain, which will react with nitrogen containing rocks, and the nitrogen in the rocks will swap out with the carbon in the carbonic acid and release nitrogen gas and oxygen gas from those rocks and fix that carbon into the rocks as carbonates. And so that will create a gradual process over several centuries, up to about 1,000 years, for the Martian atmosphere to slowly transition from a pure carbon dioxide atmosphere with a little bit of argon up to a nitrogen oxygen atmosphere that'll be a lot more like that we have on Earth. And so eventually Mars will become fully terraformed once that process gets underway. We have any questions?
Yes, yes, wonderful, Michael. Yes, we have the opportunity to questions. We have some friends here. Let us see. I believe Rosa is not getting to open. Also, Aaron, Monique, and Carver are here. If you like to interact and do some questions, you are welcome. Okay.
Sure. Carver is actually a recent addition to our staff, so she's going to be working with us on this project. And so I want to welcome her to the ISM family here. And
Yes, something to be registered here would be interesting. We explain how to common person can have access to this to the ISM. How would be this?
okay,
Because maybe you have some people that it's not here watching in this right moment, but we are recording, and maybe in the future the people will see the video and have some questions about how to has the access to the ISM.
right. So our website is ismuseum.org, so you can keep up with what's going on there. If people want to visit our facilities in Second Life, which still exist, you can go to secondlife.com, join there, and go see our regular rocket exhibit facilities there. If you want to participate in our Mars-based project, you can go to kitely.com and register there. That's where our IS Museum region is in Open Simulator. And so you can join there, install the Firestorm viewer, and log right in and join our group, the IS Museum Planners group. And we have a weekly meeting every Sunday at 6 p.m. Pacific here in the IS Museum region. And we welcome participation by people from all over.
Okay, wonderful. Yes, I also shared in the chat the address of ISM, how to enter in the website. Yes, I can see that the ISM is always growing, right? Each time
Yes.
bigger, bigger and bigger. Also more complete, and congratulations for the great work led by you. The also not only for you, but for the group that's collaborating with some gadgets, some virtual components. Yes, I don't know if you have more questions right now. Okay. In this case, I am concluding the recording, and thanks so much, Michael. Let us stop here.